Hello, today we're talking to Daniel Povey, and can I ask you, will LM rescoring improve word error rate in icefall models?
Oh, okay. So we've had difficulty getting improvements from language model rescoring. At some point, there's going to be some scenarios when it works and some when it doesn't. So I I believe we in the old setup, which is the conformer CTC setup, that's one based on like CTC plus attention decoding. In that setup, I think we found a way to get some small improvements from decoding with a language model. That's my recollection. But in the current RNN-T setup, I believe we don't yet have improvements from rescoring with a language model. Now, that is going to change, I think. So now in general, if you the problem is that the RNN-T system, it kind of has an internal language model already. So there's been this recent paper from Tsinghua University, plus someone, I think it was Mei Tuan, who they managed to get quite nice improvements by combining the RNN-T with the language model, and then they subtracted a very basic language model that's just a bigram. I think a symbol level bigram, like PPE level or something like that. They subtracted the bigram as a kind of replacement for the internal language model of the RNN-LM, and they got some nice improvements. So we're going to try to replicate that. Right now, it's not working great. We have managed to get some improvements in a situation where there's like a big data mismatch. So for instance, you know, you're trying it with like names and addresses or something like that. So if there's a super big mismatch, you can get an improvement by using some kind of language model, but we have to develop some scripts for doing that, but also subtracting a language model that represents the training data. So that's going to be a stand-in for the internal language model of the RNN-T. So anyway, this is something that we're actively working on. Right now, it is possible to do decoding with a language model, but it doesn't necessarily give great improvements if you're working on the same data that you trained on.
Okay, thank you.
Yeah.
Could you also explain the different decoding methods?
Okay, let me have a look at this. Okay, so I have to cast my mind back because this is the Conformer CTC system that I haven't messed with this for quite a while. So HLG, there's no HCLG because we don't use context dependency here. HLG decoding means like you're building a graph from a lexicon and a language model. So it's going to be limited to the words in your lexicon. So this decoding method won't be able to decode like out of vocabulary words. Yeah, so this decodes, you can see from the output that it's only decoding like real words. There's no like, you know, words that don't make sense in there, although there wouldn't necessarily be anyway. Yeah, okay, so that's that. Let's go down to the next one. Okay, HLD decoding plus LM rescoring. So I think the way this works is that we're generating a lattice from the HLG decoding, and then we're using a larger language model, still like a word level n-gram language model, to decode, to rescore the lattice, and there's going to be some kind of combination weights in there, and I think we can get a small improvement from that. Okay, let's go down one more. So this is we're adding attention decoder rescoring. So this means that we do the first pass of decoding with the CTC output of the neural net to generate a lattice. Then we do the LM rescoring with a larger LM, and then we we generate an n-best list from that lattice. We use a very simple randomized algorithm to do that. And we score each element of the n-best list with the attention decoder output of the neural net. Now, this is a lot faster in terms of latency than actually doing step-by-step attention decoder rescoring, because if you do the step-by-step thing, you have to reevaluate the neural net for every new length of the utterance, and basically it's easiest to just evaluate the whole sequence each time, which is it's a lot of wasted computation, and it's super slow. And this is kind of an issue with if you do attention decoder rescoring, if you do attention decoding in ESPNet, it's like super slow. So this is way faster than that. I don't know if the performance is quite as good as if you did attention decoding like step by step, but it's very close, and the performance is, and it's way faster.
Okay, thank you. That was Daniel Povey.
Cool. Bye.
Bye.